Good evening. It's a pleasure to be here with each one of you. It's an honor that the Lord brings us to these moments where we have opportunities to share, to encourage, to equip. I thank the Lord that He's given me an opportunity and really a heart to understand dinosaurs, to enjoy dinosaurs, and to be able to see them from a biblical worldview. I'm often reminded when I speak to audiences that my grandmother, my mama's mama, she's been with the Lord several years, she was not convinced dinosaurs were a real thing. And what I think in reflecting on that, I didn't have the sense to really have that thorough conversation with her at that time, but I think what she was dealing with is she was aware that dinosaurs, evolution, millions of years, were all kind of seemingly in a package together. And you come to Scripture and it's like, so it was easier for her to just simply dismiss them. And unfortunately, I think a lot of people in one way, shape, form, or fashion dismiss something. And I'm here to say is that is not necessary. Now, there are some right ways to orient our thinking, but the Bible gives us a history of the world. It anchors itself in a very powerful place. Being the Word of God, not only is it an account of the beginning of all things, but it comes with the endorsement of the high witness of the Creator Himself. And He even has created us to think scientifically. And so for me, there's a real importance to merge and integrate this science and theology together as we grow as believers. I don't think we have to abandon one to embrace the other. But we do have to be aware of how they function together and how we want to process some of that. And hopefully I can work through some of that for you all tonight. When I think about turning this on, when I think about growing up as a little boy and always having that passion for dinosaurs, and I imagine many of you sitting here tonight remember those days when dinosaurs were fascinating to you. And often we outgrow that fascination and we move on. This is actually a book that I had growing up. Now, what I get to do as an adult is look back through the books and see what I was being taught, and really part of the problem that was being manifested in my thinking. Because see, I've been in church. My mother tells me first time I went to church was 4 weeks old. I don't remember that day. But I can say this, she tells me I've been there all my life. And so I had that understanding of the Bible, of God, creation, the flood, 6 days, but I also had this passion of dinosaurs. And as you can see here, the first page of this book says, long, long ago, long before the days of men. What is it telling me right off the bat? That man and dinosaur never lived together. And even though it's not giving you a date, giving you time here, it's separating the two. Now, I started a hobby about 10, 12 years ago of collecting dinosaur books, and a lot of them are children's books. Part of it's just research, and I mean just anything, because I'm curious as to what they're saying. And every one of them starts with this 65 million, 130 million. You don't miss that detail. It shows up everywhere all the time. And so if you're not able to respond to that, understand why that's a faulty way of thinking, why scientists can't know that, you do understand that time is not ultimately a process of science. It's a historic process. Now, we'll talk more about how they craft their own science. One of the other things that I had as a child was this Viewmaster. Now, you all know what a Viewmaster is, right? Now, if we had for you younger ones, that's the early days of the virtual reality headset, okay? Now, Ken was showing off earlier. He told me he had one with light on it, and I'm like, wow, I'm impressed. But I remember those days of clicking away, and to be honest with you, I remember putting the disc in and scrolling through and seeing the dinosaur images. And this right here, the Triceratops and the T-Rex and fighting. Of course, now I'm seeing it through a different worldview, and I'm seeing this primordial world that they're tucked into. This world that's in this violent change, and I didn't understand what to do with that. And so these things kind of set as an anchor for me. But as God walked me through that, and it was interesting. You all probably don't think of Jurassic Park as an evangelical movie, do you? No, and you shouldn't. But what's interesting is that movie came out in 1993, and prior to that time, I had really had a weak view of Genesis 1 through 11. Really didn't view it as authentic history. And that movie came out, and it wasn't that movie answered any question, but it stimulated some thinking for me. It stimulated those questions that I had years ago and didn't know what to do with, and I had to go back and get those answers. And the Lord led me to ministries like Answers in Genesis, Institute for Creation Research, and others. I remember reading a paperback book by Dr. Henry Morris, The Beginning of the World, 125 pages, nothing fancy, but it was a scientific approach to Genesis 1 through 11. And I remember thinking, where has this been? Why have we not had this? Because I grew up in a church that believed the Bible, but did you ever hear dinosaurs or science ever mentioned in church? And I grew up with an understanding of science, but did I ever hear anything theological mentioned? And so I had these two competing worldviews that eventually bumped heads, and I had to get them worked through and resolved. And the Lord led me through these ministries and to see how science is often biased in its presuppositions. Science is good. Don't hear me say science is a bad thing, but scientists have biases. And the history of the Scripture is an anchor point that we can stand upon with confidence and with authority and strength. And this has led me to, as I see myself as a paleontologist, now I begin to interpret what I see through this worldview, through this lens. And so as I begin to go out and do my work, part of what I'm doing is I'm recognizing the need to be part biologist. I recognize the need to understand how modern animals function and move. Because we're just digging up bones. And none of them are running around. None of them are moving. And so I have to understand, what am I looking at here? Now this is what is called a metatarsal from an edmontosaur, which is a duck-billed dinosaur. On the big long bone in your foot, this is his big long bone in his foot. A little bit bigger than your bone in your foot, isn't it? And what I recognize here is this is where the tibia would sit on top. And this would be where the other bones of the foot the other digits would run out here until he hits an ungle, the hoof, if you will. And what we have to recognize is the detail, what's going on here, how do muscles attach, how do blood vessels flow through here, where will the nerves be, and begin to reconstruct. And part of our understanding, part of our way we deal with that is to recognize how do modern animals do this, and now I can make some relevant applications to that. I also had to be part geneticist, not in the absolute I know genetics, but to understand that God has infused within every living organism information into the genetic code, the DNA, and that is the starting point for how life is constructed. We all have it, and I have to understand and be reminded that that is present even within dinosaurs themselves. I have to be part geologist. As we're out digging, if I find a bone, first thing I'm thinking is I'm looking for a horizontal plane. Bones just aren't scattered throughout the hills. They're on flat level plains. When I look into the hills and I see layers, different colors of material, that's called stratification. The only way that occurs is because of water. Materials stratify because of lots of water. Bones get buried on a flat plane because of water. Now, can anybody in here help me with this? Can anybody, if we have these conditions happening globally, can anybody think of a situation of an account where water has occurred globally? You have just walked into Science and Theology 101. You understand what you've just done. Now, you laughed well, and I wanted you to, but what you just did is you recognized the biblical account, and now we go out into the field and we begin to see the evidence of such an event. Science and Theology 101. They all pass. Everybody gets certificates tonight. We also have to be part engineer. And this is really going to be so much the thrust of what I want to talk about tonight as I begin to think about the design in dinosaurs. Just to understand the mechanics, how they work, when muscles contract and move bones. How is that system working? And I also had to be part historian. I recognize, as we've already been talking about tonight, the importance of the Bible in Genesis 1 through 11 as it serves as a foundation. Now, as a secular paleontologist, they're going to have their own history, but they've got a man-made history. You'll see it in the terms of the phylogenetic tree or the geological column. But those are all man-made ideas. And they're influenced by their presuppositions that the flood did not occur. And so they're forced to reinterpret the data that they're seeing. Because see, I think the world is full of geological evidences that the flood occurred. It is everywhere. But if you don't have eyes to see and you recognize the implications, because this is the important thing, I think the flood is really cool, fascinating to look at, but when you stop and think, why did the flood occur? Because of what? The sin of humanity. It's a judgment. The flood is not some random event, some random geological event that just happened to have occurred. It happened as a direct result of God's divine choice to judge humanity. And there are profound implications behind that. When we think about design, this image is so profound to me. The prosthetic hand, nobody in this room, and really probably nobody on the planet would ever deny that this prosthetic hand was designed by a human, by a man or a woman who had a brain to think. But what are we taught commonly with respect to the human hand? It's a product of millions of years of evolution. You see the disconnect? And yet intuitively, we recognize they're both designed. They both represent intelligence. And intelligence is always the product of a mind, and a mind is always the product of personhood. God is person. So when I think about design, design is that predetermined objective of a mind processing information with a specific goal or result in view. Design is not the execution of the end goal, but the foresight, the engineering and purpose of the intended result. And so when we think design, we should always think designer also. So when we see our world as being designed, we must also recognize there is a designer behind that. Now, within the world itself, one of our favorite people is Richard Dawkins. And he says a couple of things that are really quite baffling to me, but it's intriguing. And I want you to hear this from two sides. One is you recognize the foolishness of the comment, but I want you to also recognize the sadness of the lostness and the blindness he has here. Biology is the study of complicated things that give the appearance of having been designed for a purpose. What has Dawkins just admitted? He sees design. He sees it. I have no explanation for complex biological design. Well, he's admitting it again. All I know is that God isn't a good explanation. And this is the struggle that we have to be cautious of, because short of Christ and his redemptive work for our lives, we would be the same. And we're left to this vulnerable position. And sadly, this is the position that so much of the world and men like himself dominate the sciences and dominate the ideas of philosophy that influence us and influence our children as well. And when I think about the design argument from a classical design argument point of view, the idea is called teleology. It's the end result of things. And so the idea is that from design is when I see the world, I recognize its design, I automatically recognize the designer. To design is kind of coming at it from the other side and saying the Bible reveals God as the designer and the Bible teaches that He designed the world. And so we're kind of coming to the same conclusion from two different ways, and I'm going to approach tonight in this perspective. Now, Dr. Doug Axe, this is an interesting book. Dr. Axe is part of the intelligent design movement, and I really like a lot of their stuff, except they don't ever seem to be willing to name the designer. And I'm like, part of the time I know what you're trying to do, and part of the time I'm like, why stop? Because you've got some really good information and good insights, but that was a side note. Dr. Axe here comes up with something he calls the universal design intuition. He says tasks that we would need knowledge to accomplish can be accomplished only by someone who has that knowledge. As makers of things, we instantly recognize that things that are made, and we know these things can't be made without know-how. And so there's that intuition that when we come up to a thing, we recognize that its structure, its complexity required somebody with know-how to bring that into existence. If you were to want to try to do a new skill, a new task, and you didn't have the know-how, what would you go do? You'd go to somebody who knew it and teach you. You go YouTube, you go learn it. We all YouTube everything, don't we? But we would learn and gather the know-how so that we might begin to know what to do in the process. And so what I want to do is take this premise that Dr. Axe has put before us, this universal design intuition, and kind of walk us through a little bit of a flow here. Now we have these two pictures. The one on the left I'm meaning to be visualized as a living dinosaur. The one on the right is an origami dinosaur. And so the question is, which one bears the marks of design? They both do. Which one requires information, intelligence, forethought, and design to exist? Both of them do. Which one is thought to be the byproduct of millions of years of random, unguided, unintelligent processes? Only the one on the left. You all understand that. We start here with our intuition. Insight or immediate reasoning. Our intuition says origami dinosaurs can't happen by accident. That's our intuition. We recognize the need for something more, some intelligence behind it. And I think God has really crafted our minds in such a way that we see design naturally. It's not something that we're going to miss, but it's there before us. Our ability to distinguish between that which is designed and that which is random. I don't know if this was up at the dig site. Some of you all that's dug with us. Do you remember as we get to the top of the dig site and there's that stack of rocks? We've got about 7 or 8 rocks that are just stacked up. Now we had some young people about 10 years ago stack them up. And I've just left them there. And it's really generated some interesting conversations because sometimes people will ask, did that happen naturally like that? And you can hear the wheels turning because you're like, well, that doesn't look like that happened naturally. Or you have somebody that comes up and says, I recognize, why did somebody do that? And they recognize, just on a stack of rocks, they recognize the presence of intelligence that's right there in front of them. Romans 1:19 and 20 just reminds us of this intuition that we have as created beings. For what can be known about God is plain to them because God has shown it to them. For His invisible attributes, namely His eternal power and divine nature, have been clearly perceived ever since the creation of the world in the things that have been made, so they are without excuse. And I think Paul's affirming that for us, that we're crafted to see the hand of God in creation. Now, as if you were walking down the beach and you saw these ripples in the sand, as elegant as they might be, you would recognize that they're probably just simply the action of waves randomly rolling in off the shore. And you would be right. But if you walked a little bit further down the beach and you saw this, you begin to think, this isn't the natural action of waves, is it? This is something else going on. But you walk a little bit further and you see this. Any question you had of waves randomly doing this has gone out the window, right? And we recognize this is part of how our intuition works. What's interesting is how the world, a lost world, seems to fight against that intuition within themselves and within even us as believers. Alison Gopnik says, by elementary school age, children start to invoke an ultimate godlike designer to explain the complexity of the world around them, even children brought up as atheists. Deborah Kellerman adds, even though advanced scientific training can reduce acceptance of scientifically inaccurate, those are her words, not mine, teleological, which is design, explanations, it cannot erase a tenacious, early emerging human tendency to find purpose in nature. Not only is she recognizing that, but she's wanting to eradicate that. And she can't. No, that's part of who we are. But again, these are reminders of what we're facing as we walk through. And all of this is relevant in so many disciplines. Certainly I'm applying it within the realm of paleontology tonight. But these kind of ideas are so pervasive in so many different areas. And ultimately, as Paul adds here in, I'll reread 19 and add 21 and 22, for the wrath of God is revealed from heaven against all ungodliness and unrighteousness of men who suppress the truth in unrighteousness. For even though they knew God, they did not honor him as God or give thanks, but they became futile in their speculations, and their foolish heart was darkened. Professing to be wise, they became fools. And sadly, that's what we see in the world today. In so many of the issues that are before us in culture and society, we're not seeing just another idea being grabbed a hold of, but we're seeing actually the attack upon the created order itself. And in doing so, people who hold to these positions aren't just wrong, but what Paul's saying is they're sliding into insanity ultimately. As an individual who knows God exists and can see God's hand in creation and then still deny it is a fall into insanity. Now, moving on here, our observation is origami dinosaurs don't happen by accident. Now, this is where we begin to get into the scientific side of this process. This is observation. This is data gathering. This is going out in the field. Now, I don't per se suggest that you go and sit at a paper recycling plant to see if origami dinosaurs are going to pop out, but this is ultimately the idea here, is if you were to go to a plant that recycles paper, would you ever think an origami dinosaur would ever pop out where one was not being fed into the system beforehand? Why not? Because you recognize that the equipment, the process, is not set up for that. There's no know-how, there's no procedure to handle this. And here's where this is, I'm going to preach for just a second. Deep time is nothing more than a blanket to disguise a fallen world's faulty worldview. There is no basis. There's no reason for deep time. This idea of millions of years, billions of years, is without value and shallow. I'm not unaware that some of you all may be sitting here right now hold to that position. I'm not unaware of that. But I'm telling you, that is an unnecessary, that is an unscientific position. Time does not resolve the issue here. It just doesn't. Our question is, why don't origami dinosaurs happen by accident? Well, there's complexity. Yes, you like all that, don't you? But there's complexity involved. As simple as this thing is, there's complexity involved with the process. And so we begin to recognize that we can't happen by accident, they don't happen by accident, and we recognize that to force that onto the argument is not really being honest with the data. And so if we were to walk through dinosaurs here and just simply apply this procedure of our intuition tells us that dinosaurs cannot come about by millions of years of evolutionary processes. My intuition tells me that. And our observation says that dinosaurs don't happen by common descent evolution. And this is where I begin to really struggle with what evolutionists do. Because the only examples they give of evolution functioning is what I agree with is just simply genetic variation within a created kind. If you've got dogs in here, dogs are really easy to do. A lot of you have dogs in here. Different lengths of hair, different lengths of legs, different shape of face. But any one of you would look at those animals and recognize they're all what? They're all dogs. Genetic variation. That is not evolution in the sense of how they use that. It's not the same thing. And so ultimately, I don't see there being any evidence for this process. We recognize that life is irreducibly complex, that God has created life to function fully formed right from the beginning of creation. We recognize that if we were to reverse engineer, so if you say Darwin's idea of evolution is that there were slow incremental changes over long periods of time to increase in complexity. Let's just say that's a fact. Now let's take a living organism today and let's just turn it around and go backwards, even if we're just doing it hypothetically. When you start to de-evolve an organism, do you get it less evolved or do you kill it? You kill it. Your computers, do you start taking parts out of your computers? Do they keep working? Do they work slower?
A lot slower.
A lot slower, yes. And you begin to recognize that when you begin to back things out, you just start destroying the thing that you're backing down. This is the beautiful argument about Michael Behe's irreducible complexity and the mousetrap, if you're familiar with that. And as simple as that mousetrap is, it's an irreducibly complex system. I know there was one guy who responded to Michael Behe, and he said, well, I can make it less complex, and I can make it a tie clip. And Michael Behe simply responded, but it wasn't designed to be a tie clip. It was designed, does it catch any mice? That's what he said. Does your tie clip catch any mice? And it doesn't. And so you recognize that shift there. Complexity is layered within life itself. Each system is complex, but it's complex in an integrated fashion. And the Bible affirms this case. Now let's move to design. We're going to start with Scripture. We're going to walk through this. Everybody holding up okay? All right, good. If we need to get up and do jumping jacks, we can do that, okay? Now what I want to look at is four things here. We're going to go back into the creation narrative particularly. Then we're going to move to Job chapter 40 and look at Behemoth. We're going to look at the general groups of animals. We're going to look at the created kinds. We're going to look at Adam naming the animals. And then we're going to look, as I mentioned, at Behemoth. Now, we see in Genesis chapter 1 this first step. We see God naming, the scriptures give us that God is giving us general categories. We have flyers, we have swimmers, we have land animals, and we have crawlers. These are very broad categories, but they already are separating life one from another. You're already beginning to get distinction here. On day 6, we see the same basic idea. Now, just for making sure we're here on the same page, dinosaurs are simply land animals. They're not swimmers and they're not flyers. Those are marine reptiles or flying reptiles. And so when we look at Scripture, we see that God created land animals on the sixth day of creation. So logically speaking, what day would God have created dinosaurs? On the sixth day of creation. I like to be sure we've gone over that, and that's just letting the Scriptures kind of walk us through the text, and that becomes our launch point for understanding how we move forward. Secondly, God says He created life after their kind. I've got these groups. So therefore, dinosaurs are land animals. But under that land animal category would have been several individual kinds. And what the text is telling us here is two things. One is that within the creation week, God is creating out of the ground the tyrannosaur kind. He'll create the dog kind. He'll create the hadrosaur kind. He'll create each kind as He's going through. But this isn't a static model, because secondly, what it's letting us know is that there is going to be diversity that's going to happen. So within the tyrannosaur kind, there are going to be variations within that kind, but there are going to be boundaries around it. So there can be only so much distinction. So tyrannosaurs are not becoming something else, and tyrannosaurs did not come from something else. And so that's what the boundary is for us here. Now, I debated on doing this right here, but we're going to give it a try. This is called a phylogenetic tree. This is specifically focused on dinosaurs. Let me just point out a few things. Typically, when you see phylogenetic trees, you're going to see them standing where the bottom, the single-cell organisms at the bottom, and it points up. This is laying on its side, okay? You're also going to see that we're now beginning to, paleontologists are dividing everything is dinosaur, including birds. And so there are avian dinosaurs and non-avian dinosaurs. That's just some of their terminology. You'll also see the breaking down of Triassic, Jurassic, Cretaceous. That is a system of time that's been infused and assigned to the dinosaurs. That is not something that's come from the rock record. That is a system, as I mentioned earlier, the history that's been built in to the process. This is them building it in. So what we have here is we have a particular group. This is called the sauropods. This is what I'm going to focus on tonight. These are the long neck, long-tailed dinosaurs. And you're going to see each dot or each creature here represents some modified form of a sauropod. Now, they've got it spread out through time, and evolutionists think in terms of evolution. They're always going to interpret everything they dig out of the ground through the process of time. And they're going to place it where they think it best fits in that evolutionary progression. So evolution often works by smaller to bigger, two-legged to four-legged, or sometimes within their head, a very simple head to a more complex head. And those are three things that seem to be really coming to surface. What I'm seeing here is that all of them would have existed generally within the same basic time period. So there's not going to be a distinction of time. Now remember, we just went through and looked at point number 2, says God created life after its kind, and I said there are boundaries. I see this sauropod group within the red box as a boundary of created kind, sauropods. You understand where I'm going with this? Now, this is not put together by me. This is a secular, non-Bible believing paleontologist put this together. But what's interesting, as he begins to put this together, he is putting together a created kind model. Because what you do, I had this right here. So this kind of gives you a sense of the sauropods and their kind. Now I put boxes around each group. If you were to simply remove time, you have a picture of dinosaurs and their large-scale groupings on the day of creation, sixth day of creation. And what I find interesting is these paleontologists have got this massive database they have access to, and they could really build this really incredible created kind model if they knew to think that way. I don't even have access to all the data they've got, but I do enjoy grabbing it when I can because I think it really provides an interesting. Is everybody at least somewhat grasping this? This may not be familiar to everybody, but I really appreciate and really find it interesting that a secular, non-Bible believing individual has created a model that works for the Bible for the most part. Now, we move into Genesis chapter 2, and we see Adam naming by design. It says that the Lord God said, "It is not good that man should be alone. I will make him a helper fit for him." Now, out of the ground the Lord God had formed every beast of the field and every bird of the heavens, and brought them to the man to see what he would call them. And whatever the man called every living creature, that was its name. The man gave names to all livestock and to all the birds of the heavens and to every beast of the field. But for Adam there was not found a helper fit for him. It's been easy to kind of just gloss right over this passage right here. But it's providing for us some interesting and intriguing insights. First of all, what was Adam's need? We see here in the beginning, God said it's not good for you to be alone. And Adam needed a helper that was fit for him, right? And so in the process, God brings all of the animals to Adam and he names them, but none of them are fit for him. Now we know that eventually God is going to put Adam to sleep, and out of his side he will form Eve, and he will see, "This is bone of my bone and flesh of my flesh." They were naked and not ashamed, and they were joined together, and we see that relationship being formed. But here, the animals were not that. And so when you give an animal a name, see, I don't think that in Adam, in naming the animals, is just picking them out of a hat. I don't think he's got a basket full of names and he's just handing them out as they come through. I think he's seeing something in them. God has given him the capacity to understand what he's seeing and apply a name that has great relevance. What he's giving them is, he's describing, their name connects them to the essence of who they are. Essence is the intrinsic or indispensable qualities that serve to characterize or identify something. So when Adam sees this animal again, let's say he has a lion, and he says, "You're a lion." Then he might go 3 weeks and come back, and he comes up and see. Now, we have a history of information here in us. Adam doesn't have any education here. Adam is just brand new out of the box. The animals are just brand new out of the box. And so when he comes back to this animal that's a lion, he knows it's a lion. I've named it a lion. It possesses the essence of a lion. But let's say he never sees that lion again, but 3 years later he sees the offspring of the lion. He's still going to know to call that a lion. Why? Because those offspring still possess the essence of a lion. And so he's giving them something of intrinsic value that's highly important. He was looking at their aesthetic. When he's naming them, he's seeing, and this is where we begin to kind of look at the design idea here. He's given them their aesthetic, their beauty, their body plan, their basic pattern of how they function, their movement patterns, their life systems. And so as we look at animals today, naming them is of great value. Now we're trying to understand what modern animals do. We have names for them, and then we try to make that comparison to the extinct animals. So what I'm going to do is make a comparison here of a cheetah versus a raptor and an elephant versus a diplodocus. Animals move in so many different ways, and as I've already shown you the foot bone over there, as a paleontologist, I'm trying to read how the muscles fit together, where the muscles would attach, the shape of the bones, how they would organize themselves. because I want to try to figure out, what did this animal do? How did it move? Did it jump? Did it run? Did it swim? What did it do? What enables a cheetah to run fast? Well, its overall body makeup. It's a lightweight animal, proportionally long and slender legs, long feet, minimal contact on the ground, lean, quick twitch muscles, tail for balance. Now I'm going to use that framework, that understanding, and apply it to this animal. Now, I've never seen this animal alive. I've never seen it move, but its skeleton, and as I study various parts of its muscle attachments, I can make some assumptions about how it might have functioned. And so when you see like Jurassic Park and Jurassic World, part of what they're trying to do in that process is to understand how it might have moved. If we look at an elephant, you see the general weight goes up, the strength, the body mass, the feet, the thick legs. If we make an application to the sauropod or the diplodocus, we can make some similar correlations between the two. So when we look at these two animals, what really distinguishes them? When I think about, if I were to sit here and say, an animal has 4 legs, a backbone, ribs, a head, and a tail, would you know which one of these two I'm talking about? So what distinguishes them? Well, first of all, the proportions, right? The proportions of the skeletons alone of the two are quite significantly different. And the fact that we've seen them both alive, we even know how the muscles are significantly different between the two. Secondly, is those little intrinsic, those little small qualities, often things like within the skull and the face. But even beyond that, we've seen both of them move. Have you ever heard anybody describe how cats are? They have a cat-like behavior. And when you see, do y'all have coyotes over here in this part of the, okay. I was surprised because I saw one running across the street on the way up here this afternoon. And I'm like, I saw it in the distance running across and I could see it bouncing like a dog. It had a canine look to it, but it was very skinny. And I got up closer and I saw it was a coyote, and I thought, now that's interesting. I wasn't expecting that up here. But from a distance, I could see that had no cat behavior to it. When we do the same thing with the brachiosaur, or the diplodocus rather, with the raptor skeleton, we recognize that fundamentally, if we were just to make a general description, they're virtually identical. But when you begin to look at proportions, they're distinctly different from one another. Now let's look at our fourth point here, and we'll begin to press into a specifically with the dinosaurs here with some depth. Behemoth is a sauropod. Job 40, behold Behemoth, which I made as I made you. He eats grass like an ox. Behold, his strength is in his loins, and his power in the muscles of his belly. He makes his tail stiff like a cedar. The sinews of his thighs are knit together. His bones are tubes of bronze. His limbs are like bars of iron. He is the first of the works of God. Let him who made him bring near his sword. For the mountains yield food for him, where all the wild beasts play. Under the lotus plant he lies, in the shelter of the reeds, in the marsh. For his shade the lotus trees cover him, the willows of the brook surround him. Behold, if the river is turbulent, he is not frightened. He is confident though Jordan rushes against his mouth. Can anyone take him by his nose or pierce his nose with a snare? First of all, the description here is really quite intriguing as you see this first group of verses here. It's you get quite a bit of anatomy here, a framework of what this animal may have looked like. The tail has always been very intriguing, and I begin to think about the tail and this coupled with this description of the animal. I begin to just look at every animal I could think of that had any kind of size and a tail with it. And nothing seemed to really work. And this is why I think for many years, most people have assumed and believed that Behemoth is a sauropod. And that's where I stand. I believe this is firm, and I believe that's what Job is seeing here. Now, as we look here, we're going to look at some various aspects and build off of the specifics of sauropods themselves. We see in the first here that he's a big consumer of vegetation. Yeah, he eateth grass like an ox. This doesn't mean his skull is shaped like an ox, so that he has ox-like teeth, but he is a large consumer of vegetation. And when we think about sauropods, they were certainly structured. We see the teeth, they were either peg-like or spoon-like, and they were designed for mass accumulation of vegetation here. You see the picture in the bottom left, that's the shape of some of the teeth. And what's interesting is some of the wear spots. You can see where they've been eating. I just happen to have a T-Rex tooth in my pocket. Am I the only one in the room like this? Did you not tell everybody to bring their T-Rex teeth? What's interesting, this has got the tip missing, but often we'll find T-Rex teeth, and I will say, well, that one's been used because you can see the tip's been worn off. And there are, I'll leave this on the table up here, there are little serration edges here and here to help. Serrations, think of a steak knife with little divots in it, and so it helps cut through. And so it's interesting, even within a fossil, you can still see the use. You can still see where they've been eating. And that's what we're seeing here, is this guy was using his teeth. Now, when we compare this to the two versions of sauropods, the Brachiosaur and the Diplodocus, you can see the teeth on the Brachiosaur, his dentitions go in deeper into his mandible and maxilla, deeper into his mouth. And that suggests that he possibly had some ability to chew some of his food. Certainly was stripping vegetation off the plants, but may have been able to chew it a little bit. The purple here is the main muscle that attaches right here on the proximal end of the mandible, and would go up in through the skull and tie off an anchor up in here. They're building off here just the best place for this. You're looking at muscle attachments. You can see sometimes scarring in the bones where tissue was attached. Different dinosaurs have different points of contact. Here with the Diplodocus, all of his teeth are out here on the edge, and so he likely had no capacity to chew any food or break it down. So he was just stripping and swallowing, stripping and swallowing. And so there's been thoughts of possible what they call gastroliths, maybe have had stomach stones to help break up some of the food. That's kind of gone back and forth. Stomach acids, how long would the food have sat in his stomach? Did he have multiple stomachs? So those are things you can't know from the fossils alone, but they're beginning to try to make some logical assessments here. And again, you see the muscle here that would have brought the jaw closed, is attaching back up into the skull itself. One of the other things I find interesting, I would put both of these sauropods in the same created kind, even though their skulls are quite different. Because when you see this with dogs here, you'll have like a collie or a German shepherd, you get more into a Labrador or something like that, and then like a pug right here. They're all of the same created kind, they're all the same dog, they're all dogs, but their skulls are quite different. And so I kind of make this as my model of what I see today and make application to the two on the left. As far as what they ate, it's what's called gymnosperms. They're more conifer type material. You may be thinking, well, how do they know what they ate if all they've got bones? And that's really a valid question. The best thing they're looking at is, and we run into this, I don't remember how much, Ken, you remember, but as we're digging in fossils, we're also digging up plant material. We'll find little sequoia cones. We find broken down pieces of tree. We'll find not in a good shape tree trunks, but we find lots of layers of coal. And so within the fossils themselves, we have a lot of plant material. And so you're just kind of making a logical assumption is if the plant material is with the fossil, likely there's a good possibility that's what he ate. And so that's what they're building off here. With the range of motion, the Brachiosaur is the one that kind of had a little bit higher forelimbs. The Diplodocus was very horizontal. They don't think either one of them really were very much in raising their heads up very high. The Brachiosaur possibly, but the Diplodocus likely anchored himself in a spot, and with that long neck, he just kind of goes out and just starts eating and just kind of working through, and then moves in a little deeper and eats and just consumes that way. And so they had probably a very functional, and this really begins to get into the biomechanics, computer design, computer generated images to kind of begin to get a sense of what's even possible. When we think about the neck itself, if y'all can do this, if you are up to it and interested, just stick your arm out to the side. Hold it out here. If you're not, that's okay. Now, for us as humans, think of our fist as the head, and our shoulder is right where the shoulders would be the forelimbs right here. Now, what is holding our arm up? This deltoid right here, right? And so that becomes the main point at which this stays up in the air. But after a while, you're going to this is starting to burn, starting to hurt, and you can drop it now. Thank you. But what you recognize is we're not designed to walk around life like this, are we? We're just not. Not to mention it doesn't look right, but we're not designed this way. But if you're a Diplodocus, you're living life like this. This is every day, all day, like this. So you got to say, all right, so what systems are in place here to change that? Surely God just didn't throw a few muscles right here at the shoulders and say, you're good, I hope you figure it out. Well, as we know, we've just got a long bone here in the humerus and the ulna and the radius right here. So we've got long bones, and so our arms are doing something different. When you think about a neck, there's a series of vertebrae that run all the way through here, and so there's a system that's working together. If this were the shoulders, and this would be the forelimb right here, then put the head out here. And so this kind of construction crane, what makes this, when this boom right here slides out, or this crane, this hook, should I say, slides out to the end, what keeps it really strong is this one cable that runs all the way out. And what's helpful here is the height of this. So if you made this really short, you're not going to really maximize the efficiency, are you? But if you really needed to get it stronger, you could probably just make it taller. You could also, and I added these two blue in here, you could also add anchors, cables in there to help stabilize. And all of a sudden, that load that would become too much is really minimized. This is at the Utah Fieldhouse right here. First of all, the term Diplodocus means double beam. And starting the vertebra right here, they're called processes. So you've got the centrum. Most animals and dinosaurs have a single process that sticks straight up. The Diplodocus has two that stick straight up, so that's where they get the double beam. And that gets all the way up into here. You'll see some of the pairs up into here. But you get into the neck, and I've tried to draw along here, and across the top of these, the yellow line represents one, and the red line represents the other. And so what they would have is tendons that would sit along the top. So now you've got, it's not a muscle that's working, but you've got a tendon that keeps a sense of rigidity that's constant. Some of the duckbill dinosaurs, I need to add that picture in here. Right along their backs back here, where their tails kind of get out here, their backbones, all these processes are just filled with tendons. And that's to help give a little flexibility, but it's helped to kind of really keep it strong and stable without having to make the muscles work all the time. Here's a cross section right here, and you can see this green is meant to be that same tendon that runs through here. Now, another thing that's interesting that is helping is our bones have a sense of density to them. But what God has done here is this diverticula. there are chambers that they feel like had air sacs in them. And so all of these vertebrae had chambers inside of them to help lighten the load. So you've got a lighter than normal bone, then you've got tendons that are holding here. And all of a sudden, this system begins to work in a much more unique and efficient fashion than you might think. He would also have muscles that would integrate. As I mentioned, as we did our exercise here, you're working just this muscle for the most part right here. He's got muscles all through the neck integrating themselves into each and every vertebra. We see here with horses, kind of the same thing. The white would be, these are ligaments here, and they all anchor themselves back into the shoulder area with the muscles in the neck as well. And so these, again, God has crafted a way for these animals to exist and function well. I think it probably goes without saying, but I will say, these sauropods, these long-necked, long-tailed animals, are literally the largest animals that have ever walked the face of the planet. Literally. And some of their sizes are just beyond imagine. We're talking animals that are 75 to 100 feet in length, 25, 50, 75 tons, can look in a 5-story building window. Now we're getting on the biggest ones, but I mean, you're talking an animal that really defies what you can comprehend. They would dwarf an elephant. Now, this neck thing, one of the things that they've got to do is to be able to get water. Now, if the brachiosaur, which is a little bit elevated in its angle, now they can be somewhere in the 50-plus range in height. So his head's up here, his heart's about 30 feet below his head, and he's got to take his head down to the ground to get water. Now, have any of y'all ever tried to just bend over and then stand back up real quickly? Doesn't go so well, does it? And so when I think about this, God had to have infused some system. You can't just have brachiosaurs just flopping over and dying. They're not going to survive. And so there's a couple of things they've thought through is with respect to size of his heart. Did he have some regulation system along the neck? Or he just never lifted his head up high? And I don't think that's the case. We look to the modern animals once again. We're looking at giraffes as an example. I think they offer at least some plausible solutions to what God may have infused. They have in their necks regulatory valves so that when they bend over, blood just doesn't rush to their brain and explodes. And certainly the opposite would be true. They have veins that are equipped with valves and thick skin around their legs. If any of us in the room who wear compression socks understand the value of compression socks and what they do for us. And so I think this is at least reasonable. I think brachiosaurs would have had huge hearts. This heart is a real heart. This is from a blue whale. Blue whale beached itself several years ago. Marine biologists took the opportunity to extract the heart and to prepare it for display. I only do this because the blue whale in its comparable mass, its mass is comparable to the brachiosaur. And so I think, if you're thinking, how big was a brachiosaur heart? Well, what's the biggest thing we've got today? And that seems like a logical correlation. But you're talking 12, 15 inches across right here. You could stick your head in that. Just to kind of give you a point of reference. Pumps 58 gallons of blood per beat. I mean, it's just amazing. So again, it's just a reminder of the immense scale up that we're talking about of what God has done, what we know the blue whale's experiencing, and likely what these sauropods were experiencing as well. As we look deeper into the skeleton itself and I begin to think of how its system is built, I think of it much like an arch truss bridge. Let's use this picture here. And when you begin to think about the legs, the hind limbs, the forelimbs, and this would be the backbone right here, and it's carrying a lot of load. Let's go back one here. We've already been talking about the neck vertebra, and in a general sense, they're much more elongated. Now, I mentioned the hollowness within the bones, but in a general sense, from here to here, there's a general longness to them. When you get to the tail, they get short and tall again, but they get longer as you get out. Here in the torso, these are called the thoracic vertebra. They can't be long because that's where most of the load is being carried, between the shoulders and the hips. This is a Triceratops thoracic vertebra. But what I want you to see is generally how shallow it is this way and how much taller it is proportionately. And if you look at the neck on there, you see that it's much longer. Now think about it from a mechanics standpoint. If I had all of my weight that was being pressed down, and these are a series of these. So you think about having 10 of these in a row here, and they're stacked together right here. This shallow through here keeps things tight, and the height right here helps kind of stabilize things with ligaments and tendons across the top, and it actually helps maximize carrying load. And it's one of the ways that helps us to distinguish what vertebra we've got is really its overall shape, its general, is it longer or shallower, and that helps me to know where it likely landed within the animal itself. And so when we begin to think about this, with so much of its weight being carried between its hips and its shoulders, it's going to be pulling down the stomach, the organs, the ribs, and that's what this bridge is doing. Most of the weight is being carried from those cables suspended across that arch right there. Now what's interesting is the Bible mentions, I don't have the passage here in front of me, the belly of the behemoth is the center, the navel is the center of his strength. Paleontologists have figured out that the center of mass of a sauropod is right in front of his hips or where his belly is located. And so what the Bible is affirming is when you see that animal, you're going to recognize his strength, his core of strength is just right there at his hips and in his stomach. And paleontologists come along and affirm that very fact. So when we have this, well, here it is. I should have just jumped ahead right here. So you see the passage here. And so when I think about this animal, I think about it in terms of this. Now, if you had a T-Rex, they're doing something different. They're more functionally in a structural manner where they have two cantilevers. And so the tail, and this is an interesting thing, and I'll get to this in a minute, but they used to think of dinosaurs as reptilian tail draggers. But what they figured out is that, I'll tell you why in just a few minutes, but they've recognized that what this gives is a balance. So this tail becomes a counterbalance to the head and helps equalize, and so it works as like a fulcrum. The tail is where I want to land here, and this is my last section here. If y'all hang in there just with me for a few more minutes, okay? Because this is really, when I first was introduced to Behemoth and the tail was mentioned, I thought that was the thing. And I think it still is, but there's more that's an integration of all of the hips as we've been talking about the center of mass. We read here in 16 through 18, "Behold now his strength is in his loins and his power in the muscles of his belly. He bends his tail like a cedar. The sinews of his thighs are knit together and his bones are tubes of bronze. His limbs are like bars of iron." And so you see this complete description of strength of muscles and bones and tail. They're all working in unison with one another. As I mentioned, the early days of thinking of what sauropods look like and dinosaurs in general were very reptilian, where their tails drug the ground. This was one of the early drawings, which I find very silly, but this was one of the early drawings because they thought of them as very sprawling animals. And they thought, but you begin to recognize how really silly that is, and really not even just silly, but it's functionally, it's really impractical. You know it? And you even think about an alligator or a crocodile. They function somewhat like this, but their bellies are flatter. But when they want to go fast, have you ever seen them when they want to go fast? They get up, don't they? They get more efficient, and that tail gets off the ground too. Well, the Carnegie Diplodocus was one who was kind of buying into this as well, and you can see once again the tail is on the ground. The problem they began to recognize is that as they began to discover trackways, is there were no tail drag marks. And that began to be a problem. And not only that, as you see the position of the feet, they're not sprawled out, they're actually, it's called parasagittal stance, they're actually under the animal itself. And so they begin to see a much more functional and active animal here by this fossil record. And so as you begin to look at trackways in the feet, they believed they walked much like elephants do on their toes. Their feet weren't sprawled out, but they were walking on their toes. And so you can see some of the trackway shapes, but they think this is an elephant foot right here, that they may have in fact had a fatty cushion under them. And part of that is the way of the track, the shape of the tracks. If all you've got is bone that's here in the front, but you've got more of an oval-shaped trackway, something is behind it to help lift it that way. My wife was very gracious to let me go to a dinosaur trackway site on the way home and to stop at 6 unscheduled dinosaur museums on the way home. You need to meet her because she's really loving and gracious. I said, look, another one, let's stop. But this is a sauropod trackway site. There are only about 14 or 15 here. You can see we've got the cones marked. We spent a lot of our time trying to figure out with 4 limbs, and they also turned. So he went to here and then turned up the hill. And so it was really kind of challenging to figure out which is left, which is right, and particularly turning the direction here. But you can see the general oval-like shape in the ground. Now this is rock. What I found was intriguing here is if you're stepping in mud and you're pressing yourself forward, you're going to have a gush, is that a good word to use up here? Of mud come up behind your heel, right? This rock right here is kind of layered like he put his foot in and the mud just gushed out behind him. And so it's intriguing. That's probably, you can see my shoe, the size 13 right there beside him. There's the series there. Now the thinking here with respect to the flood model is that this material was deposited almost concrete-like. If you've poured sidewalks or put fence posts in the ground, you understand that bag of quickcrete. But there's also a window that's still wet, pliable material. Even though it's firm, you can still step in it. And once it solidifies, it's there. And what they're thinking is that the flood was a progressive event that would have washed sediment in, not killed all the animals, then washed back out to an extent, and left this material for them to walk across. They're trying to find food, trying to survive, trying to do whatever chaos is going on. But then it solidifies and gets buried later, and then eventually would be uncovered through post-flood processes. With respect to the tail, and this is my final point right here, when I think of a tail here, I think of the tail swaying. I used to think of it as almost like a dog wagging its tail, but that's not what's going on here. I think of it in terms of like a tree rooted in the ground, and the ground is the hips. And so the tail is gently moving back and forth. Why is that? Well, I came across this right here, this muscle attachment here. We see in a lot of the femurs, this bulge right here in the back is called a trochanter, and this muscle is called the caudal-femoralis longus. The crocodiles have them as well, and they're attached to the same way. And so what creates the ability for the crocodile to move forward is the backward movement of the femur here. And it does so because this muscle attaches here into the tail. And so this is hypothetically, this is a picture with the T-Rex, is the caudal-femoralis would tie into the back of the femur and then run into his tail. And when that muscle contracts, it draws the leg backwards. Now, one of the residual byproducts of this is something that's called yaw. So if you were looking on top of a sauropod, which would have also had this caudal-femoralis, is that as each muscle is pulled back, it would have actually rotated his hips just slightly. He's not trying to do that on purpose. That's just simply the action of the movement. And so when that tail, when he starts to walk, this tail begins to sway. And so two things that the Job 40 passage is telling us when it says he sways his tail like a cedar, it's telling us, one, the tail was up off the ground. In order for it to sway, it has to be where? It has to be up. And if the mechanics are correct in what we're applying here, then the swaying of the tail is not an activity that he's trying to accomplish because he is happy. It's simply the action, it's simply the action of walking. That's all it is. Now, I know they can do more with the tip of the tail, but right in that hip region, and you think about what Job 40 is doing, is it's really focusing all of its energy right there on the belly, the hips, and the tail. And that's where the center of strength is for this animal. And I think that's all that's being described here. Let's stop right there.